Let's look at some percent and proportion word problems. These are all problems that were on homework that were sent to me by students who were having some trouble. Here's a question where we talk about a vacation trip. Now, this is a vacation, and we have a lot more information than we need. We talk about 2 adults, 2 children. We talk about how much they spend for lodging and food on vacation. But that's not really what this question's about. This question is about how much money it's going to cost them to go on vacation next year. So we look at the cost this year, which was $95 and $103 because we have to do their food and their lodging. So that's $198. But that's this year. It says next year they're expecting it to go up because costs go up usually. Inflation means they go up. So it says they go up 4%. So we can actually set up our percent proportion by putting the 4%, 4 over 100, and then we can say that 198 is currently 100. We want to find out what 4% would be. We can cross multiply and divide, and we get x equals 792. So you might be tempted to say, great, I solved my proportion, 4% is 792, so the cost per day is going to be 792. Except in this problem, it's asking us for the cost next year. Is it only going to cost $7.92 next year? No. We need to take that total cost next year is going to be the 198 and add the 792. And so our total cost next year is going to be 205.92. I like word problems because we have context. And so you can say, does it make sense that the answer is 792? Well, no, because it should go up from what it was before, which is kind of a hint. We need to add that to what we had this year.
Compute the total cost per year of the following pair of expenses, and then complete the sentence. On an annual basis, the first set is blank percent of the second set. So the first thing we need to do is annualize this. $12 every week. We need to multiply by how many weeks there are. There are 52 weeks. And so that's going to give us our number there. 134 per month, we need to recognize that 134 each month, we need to multiply it by 12. Now, since we're putting it as a percent, that means that on top, we're going to put the first, since it's a percent of the second. So I'm going to say 12 times 52 divided by 134 times 12. And let's see what we get. I'm going to type this in my calculator, 12 times 52. And I got that, and I'm going to divide it by 134 times 12. And I got 0.388. But if I want to put it as a percent, that means I'm going to put 38.8%.
In this question, it's very tempting to be like, yeah, that makes sense. So let's read it. If the profits in your consulting business increase 6% one year, and then they go down 3%, they decrease the following year, can we just subtract those? Can we just add percents together and subtract percents? So the answer is, can we just say $6 minus $3 is like having $3? And the truth is we can add money, but percents do not add or subtract. They compound because after it grows 6% in the first year, when we decrease 3%, we no longer are decreasing 3% at the same rate. So since percents compound, we do not add them together. So what we actually do is we multiply. Now, percents need to be turned into decimals before we do anything with them. So we're going to take the 1 plus the 6% to show that we're going up 6%, and 1 minus 3% to show we're going down 3%. And then we're going to multiply those decimal values together. If we multiply 106 or 1.06 and 0.97, we get 1.0282. So that's to say that, hey, it didn't equal exactly a 3% increase. It actually was a 2.82% increase over those 2 years. This question is another one where we're trying to make sense of percents. So this says, if John earns 20% more than Mary does that mean that Mary must earn 20% less than John does? At first, we're tempted to say, yeah, it's the same situation. We just changed our reference. However, if we switch our reference value and the compared value, it actually changes the difference percent. And here I want to give you an example to show it. So our example is that Mary makes $50 a day and John makes $60 a day. So John makes a little bit more. What percent more does John make? Well, we could use our percent change or a percent difference formula, which is to say we're going to take that John, subtract 50 and divide by 50, and that'll give us 0.2. And when we multiply by 100, we get a 20% increase. And so we would say John earns 20% more than Mary. In this example, $60 per, I said year, but per day, and $50 per day. That means John earns 20% more. However, that's because we're talking about Mary as our reference. The $50 on the bottom, the 50 is typed twice. If we were to do the same problem and we were to switch the two numbers, switch the 50 and the 60, and switch the places, that tells us our reference in this case is John. So if we were to switch the 50 and 60, we do 50 minus 60, and that would give us a negative 10. Then we divide it by 60, and then multiply by 100, and we would get a negative 16.7%. So whatever number is on the bottom, that's our reference. So that says how they reference to somebody else. And so in this case, John's on the bottom, John the 60. So we're saying Mary actually earns 16.7% less than John. Notice that by switching where the numbers were, we actually changed the percent, not just the sign of the percent. Be careful. This is one that somebody sent me, and they did a great job, and they got 316, and they were wrong. The answer was 317, which is easy to make. They could have done one of two mistakes. The first one is they could have rounded as they were going, and so they lost some of the decimals as they're going. So don't round until you're done with a problem. Or they could have just rounded incorrectly. And so I typed it in Desmos, and Desmos actually has a round function. So does Microsoft Excel. And so if you type in round, it'll round it to the nearest whole number. And so I did round, and this is 316.7, and so it rounds up to 317. Suppose that a life insurance company insures 800,000 50-year-old people in a given year. Now, not all 800,000 people are going to die that year. A life insurance company, the way they work is they charge everybody, and then they only pay the people who die. They only pay the death benefit when you die. So what we want to know in this problem is how much profit or loss are they going to make. So if they make more money than they spend, that's profit. If they have a negative number when they subtract those, they end up with a loss. So let's talk about how much they're going to bring in. They're going to bring in a lot of money because they're going to insure 800,000 people at $100 per year. So for every one of those people, they're going to make $100. That's a lot of money. But we also need to factor in what they're probably going to have to spend. Now, they're not going to have to pay everybody. They're only going to have to pay 5 out of every 1,000 people. But they're going to pay them a lot. Those people are going to get 55,000. And so when we do the problem, we need to take that into account by doing that death rate, multiply that death rate by our expenses. Now, in this case, if I actually run those numbers, they end up getting a negative. They end up not making enough money. They actually have a $140 million loss. I typed it in my calculator, and it turns out they need to charge more than $100 per year because that's not going to cover 55,000 for all the people that die. Coal burning power plant generates 1.6 gigawatts of power. Now, a gigawatt is a billion watt. I do tell you that, but giga as a prefix always means billion. And then what we're going to do is we're going to answer 3 parts of this. There is a bit that throws people off. It doesn't tell us how many hours it takes to generate a billion watts. And that's because a coal burning power plant runs 24/7. It runs all day, every day. And so Our first question says, how much energy in kilowatt hours can the plant generate each month? So we're going to take the 1.6 billion watts and we're going to multiply it by how many hours are in a month, because it runs the whole time. And then we're going to divide it by 1,000 because we want our answer in kilowatt hours. And so that would give us 1152 million kilowatt hours. Now the follow-up question to this is, how much coal in kilograms is needed by this power plant each month? Well, you might think this is weird to be doing this problem this week on this homework when it's one of these unit problems, right? No, this is proportional reasoning. So they tell us that 1 kilogram of coal is 440 kilowatt hours. So we're going to set up a proportion with 1 kilowatt of coal, or 1 kilogram of coal equals 440 kilowatt hours. And if we match up our units for the whole power plant, then we can actually set up a proportion, and then we just need to cross multiply and divide to find how many kilograms of coal are needed. We can do the same process actually with part C, which is we can set up a proportion. This time it's talking about kilowatt hours. Wait, we already know the kilowatt hours for the whole month, for the whole plant. And they tell us one home is 978 kilowatt hours, and they want to know how many homes would it be. Well, this is just going to be a proportion where we can, again, cross multiply and divide. This question is asking us about the accidents per 100,000 flight hours. Now, there's a lot of information that's put in this table, but we don't need all of it. We are also only talking about the year 2002 and 2011, so they also have information about the year 2008, but we don't need it. So we want to make sure we're using the information we need. We aren't asked about fatalities, we're asked about accidents. So I'm going to take the 1,517 accidents, and whenever we say per, that means divide. So per 100,000 flight hours means I'm going to divide by 100,000, and I'm going to divide by flight hours. And so the flight hours in 2002 was 23.9 million. Be careful, don't just type in 23.9 because that's 23.9 million. The same thing is true for 2011. We're comparing 2002 and 2011, so we're going to run the numbers there. And hopefully we'll be able to get two fractions or two decimals, and less accidents would be safer. So what we're hoping to see by this measure is that aviation has become safer over time. And we'd see that if the later one is lower than the earlier. Each year there are 4 million births in a country, and there's a lot of those births are just one baby, but occasionally you get a twin birth. And so what are the odds that a mom who's pregnant is going to give birth to more than one baby? So if we assume it's all random and we don't do, we just assume classical probability and that it's randomly distributed, then we say the total number of births on top and on bottom and the number of multiple births on top. That is to say, they could have twins, they could have triplets or quadruplets, and let's assume there's not that many people that have 5 or quintuplets or octuplets. So we'll just stop there. We'll just stop with the twin births, triplet births, and quadruplet births. If we're talking about births here, we don't need to double the twin births to make babies, because we're only talking about the mother and giving birth. We're not talking about how many babies there are. The follow-up question I could ask you, though, is instead of talking about the probability of a mother giving birth to multiples, I could say, what's the probability that a baby that was born is a twin, is a multiple? So in this case, I would put the total number of, not births, but the total number of newborns, babies on the bottom. Now, the first question said there are 4 million births, but that doesn't mean there's 4 million babies. Remember that we're counting every birth once, but some of those births result in more babies. For example, if there's 124,000 twin births, we have an extra 124,000 babies above the 4 million that we already counted. So we need to count for those like that. Lastly, you could actually calculate the probability that they're not just a twin, they might be a triplet or quadruplet. This question asks us about the pounds per person per month. So we're going to start with the pounds. In the question, it gives us pounds, 7.5 billion pounds. And then it says per person. Now, per means divide. So I'm going to divide by the number of persons. In this case, it tells me there's 301 million persons. And then it says per month. So I'm going to divide by, well, how many months? Well, this is talking about in a year, so there's 12 months. It didn't tell me that in the problem. I'm smart enough that I know there are 12 months in a year. So since it says per, I'm going to divide each time it says per. So I'm going to take 7.5 billion, divide by the 301 million, and divide by 12. I'm going to type it in Desmos. I like Desmos because I get to type it in. I want you to remember to not just type in 7.5, but 7.5 billion. So what I did is I typed in 7.5 times a billion, and I typed in 301 times a million. And what this says is that per person, they're eating a lot of candy. I want you to notice I used the rounding function, and it said type an integer or decimal round to the nearest tenth. And when I tried to get it to round to the nearest tenth, I put comma and then 1, so it would round to 1 decimal place. But it didn't give me any decimal places. Well, why is that? Well, if we look at the number we got, 299.0, then, well, the number we got, when we round it, it would be 0.0. So it also says as necessary. So we're not actually going to need to put a 0.0 there. If you put 0.0, that's fine. If you put 299, that's fine too.
Try a couple of these on your own. Feel free to throw your answers down in the comments, okay? First one, we have 86 problems on the test that we got right, and we got a 98. So how many test questions were there? There's obviously more than 86 because we didn't get all 100%. We also have one where we have that Manuel found a wrecked Trans Am, and he knew he could fix it, so he bought it. And he bought it for 65% of the original price. So what did he pay for the car? So he didn't pay $7,200. We need to find out what 65% of that original price would be. Make sure you give me an answer in dollars. Throw it down in the comments, and you can see if other people agree.